Hi everybody and welcome to another video. This morning I saw something that caught my eye, and instead of like normal people who just would move on, I started wondering how I'd model it. And that was machine guns. More specifically, the sort of heat protection barrel thing that you get on machine guns, the one with these holes in. They come in also these sort of rectangular holes with a semicircle on the end, or an exact radius anyway, and got to thinking how you would model that. And quickly before I actually go on, what you're looking at here is something called Pure Ref, this artboard thing where I'm displaying all my references, and it's absolutely brilliant. Instead of having all individual photos open with Windows crappy photo viewer thing, you can stick them all inside like a big reference board, and you can move around and zoom in as you want. And I recently discovered this, and it's completely changed the way I work with my reference photos. It's absolutely brilliant. Pure Ref it's called, and I'll put a link down in the description. You can check it out yourselves. So back to the task, and I want to basically make a cylinder with holes. Or in this case, I'm actually going to try this one, which is cylinder with these sort of rectangular holes with like a radius at the end, each end. So off to cinema, and what I realized actually very quickly, it's very similar to the last video I made where I showed you how to make holes inside of a sphere using splines, generators and deformers. And it's pretty much the same technique, but just using a few different tools and going about it a slightly different way. And I thought it'd make a nice video. So let's go back to a start page, and like the sphere video, I'm going to start off with a rectangle spline, and everything hangs around this rectangle spline. This is how I'm going to construct my cylinder. And again, I'm going to create an extrude, and with holding Alt, it makes my rectangle spline a child of the extrude object. So I'm going to move this up out of the way a little bit, and so that's my building blocks of this scene right now. So with my extrude object, if I go into the caps, this is where we're going to find the magic parameter that's going to make all of this possible, the same as the last video. And I'm going to change the cap type to quadrangles and use a regular grid. And a couple of things you can see straight away in the viewport is that it's just a mess on the edges. That's because the rectangle subdivision isn't matching. So let me turn the lines on so we can see what we're doing. So I'm going to change the default subdivision for a rectangle, which is set to adaptive, which is silly. For some reason it's set, I don't know why the default's adaptive. Let's change that to natural, and it's a little bit better. And now we can, if we just up this, you can just check out this corner. You can actually see the subdivision going up and up and up and up. And if you are lucky, there we go, you can actually hit a sweet spot where you end up with the exact right amount of subdivisions, which is 39. How that works, I've got no idea. Somebody who's clever with maths might be able to tell you, but I can't. So we've got a perfect quad grid now. Let's make it a little bit thinner. Doesn't have to be that thick, it's quite thin after all. So there's our starting point. In the previous video I used a wrap deformer, but this time I'm going to use a bend deformer. The first thing you see with a bend deformer, whenever you create it, it's actually a square, and it's very difficult to see what's going on. Like, where does it bend, like what direction? You can see here there's a little handle that I can use to control the bend, like manually. But if you look inside the attribute manager, it is actually changing two parameters at the exact same time, and that's the angle and the strength, when in reality all we want is the strength. So if I set these back to their default settings, which by the way, if you right click on these two little arrows, it returns them back to their default state, which is 0. Little trick. So yes, strength is what I want here. and you can see that happening now with the viewport elements in the viewport. But this is where we're going to have to start doing some rotating and positioning the deformer into the correct position to be able to deform our subdivided surface here. So again, if I hit R to get the rotate tool, I'm going to start rotating it roughly into the right position. Now what I can do right away is actually, if I grab both of them and hit G, this now creates the right hierarchy inside of the object manager for the deformer to start working. But it's not quite right, you know, it's the wrong size, it's smaller, it's got this ridiculous wide shape, and it's not going to deform in the right way. If I do this to 360, it's, you know, it's not a cylinder and it's not really very good. So there's one easy way of being able to automatically make the deformer fit the object, and let's use the fit to parent command. But fit to parent in this case is only going to try and make the deformer fit to the null object that it's under, which is its parent. So there's a quick way of doing that. If I take the bend deformer and drop it inside the rectangle, which after all is the actual shape and size of our deformed surface, if I now hit fit to parent, we get a mess, but they ignore that. So if I put it back to its position where it should be, all of a sudden my bend deformer is the exact same size as my plane, my original plane. So if I do this, set this to 360, oops, where's my number cap off, there we go, 360, and I'm going to raise this up a little bit off my floor, and there we go, we have now a nice tube, perfectly shaped tube, being deformed by our bend deformer. And again we can see that in fact there's no stretching going on, because all of our quads are still quads everywhere we look, which is great for having to work with cylinders and circles especially. So at this point we should start adding holes, and to give you a quick recap of how we did that the last time, the trouble is with deformers and generators, we can't actually see the original spline that we're working with because it's hidden out of view. We can see it, we know it's there because we can see the bounding box, but we can't actually see the original spline. This is where it's great to start using instances of objects to be able to get at the original object. So with the rectangle active, we can create a instance and we can exchange these two objects in this extrude, and all of a sudden there's my spline object. Now I can arrange my scene in such a way that I can see both what's going on. Great. Let's make it a little bit longer. There we go. It's a bit longer now. It's not a square anymore. If you can hear that banging in the background, that's actually the loudest known noise in the universe. It's the two 5-year-old twin girls that live above me, and they're absolutely, I'm a nervous wreck here at the best of times. Right, carry on. Yes, so we've got our nice tubular shape, and we need to now start adding holes. And we do this by adding a circle to the exact same position in our rectangle, because there's no point adding it a circle over here where it's away, because it's actually part of this plane. So let's delete that one, and with our rectangle selected, we hold down Alt and we create a spline, and it will put this circle spline in exactly the right position. Let's scale it down a little bit to begin with. Now these two spline objects are actually still physically two objects, so the extrude object isn't going to be able to work with them. So there is a tool that we can, without having to remove the parametric properties of these two objects, we need to be able to combine them together into one, and we can do that using the connect object. So if I drop those two into our connect object, and then tell the reference object to reference our new spline, we get a mess. This is because we haven't taken care about how we arrange our axes in our world coordinates. It's not really an object manager problem this time. It's an actual physical position problem in world space of our connect object. Now what's going on? Well, the problem is our reference object was referencing the rectangle, which is right over here, and that's our starting point for the extrude object to start working, because it's actually extruding the rectangle. So if I activate the rectangle, and this time again by holding the Alt and creating the connect, I'm actually creating the connect object now in the exact same position as the rectangle. I'll add my spline, add it to my reference object, and all of a sudden you can see everything's back to normal, because our reference is this point in space, which is the exact middle of our rectangle. And even the circle doesn't matter anymore, because our reference point, as I said, is the axis of our connect object. So I can start moving this around, and this is actually the technique how I like to use to quickly add holes into curved surfaces, or into this case a cylinder. And it's really great, it's really quick, and you can move it around like that and scale it and whatever you, and it doesn't even have to be a circle. You can in fact use any spline. So let's just grab for example, star shape, take that out, and if we scale this down, all of a sudden you can see the star in our curved. But again, with everything, when using with anything that has an intermediate points, or basically a subdivision type, they all need to be working together. And right now the adaptive subdivision doesn't really work well with a uniform subdivision. So if we make that also uniform, all of a sudden you do get this nice match up, and the star is actually now following the curve. And if we turn the lines off, you can see it's now a nice perfect star cut out of our tube. And you can, like I said, you can do that at everything. Even the cogwheel works very nicely. Scale that down a bit. All of a sudden you've got a cogwheel, and you can even rotate it and do cool stuff. You could drag a copy and have do gear wheels, and you could rotate and animate those anyway. But today we're concentrating on the modeling. So let's drop our circle back in, and if we go back to our reference images, I was actually wanting to have a look more at this type, this sort of rectangle with circular ends. And so I don't need the circle, unless I've got a rectangle already in the correct position. I'm going to make a copy by holding Control and drag a copy in the object manager, and I'm going to start to just scale that down, and then I'm going to use the attribute manager to sort of roughly, I guess it's like that. Normally I'd have a reference image and I'd be measuring proportions, but for this video this is good enough. And then to get the actual curved ends, I can just hit rounding, and all of a sudden, if I bring that up to its maximum, which is 13.6, which is exactly half of our height, we get a nice perfect half circle on each end of our rectangle, which is perfect. And do I want to scale it up? Let's have it like that size. So now I have to evenly space these over my tube, or in this case with inside this rectangle spline, and then the deformer will do the rest for us. Well, a couple of releases ago, Mograph had a little, or the Mograph Cloner got a little update, and it received a whole new function called, oh by the way, I should jump to step there. If I hold Alt, and whenever I create a new generator or something, it's going to automatically make the spline a child of our cloner object, which then can, as you can see, starts immediately doing its job on the tube and inside our splines. But anyway, the update the cloner received was a new mode, which is Honeycomb, which is absolutely perfect for this particular job. As you can see, that's though the default settings are a little bit more than what we actually need. But that's pretty easy to fix. If we go to the size and height, we can then start bringing these in. If I start with, start with the width, I can start bringing, width, make it a little bit bigger. Let's bring the height down. So basically, all you're wanting to do is, that'll do. So make sure everything fits within inside of our main, or the first rectangle that we created, and then it's going to show up inside, well, on our deformed extrude surface, as you can see now in the viewport. So it's looking great already. So to do it properly, you would fiddle about with these for a while and make sure everything's the right size, but as you can see, it's all working nicely. But there's one thing, if I turn the lines on, all of a sudden you can see it's very too subdivided, and that's because I used the original spline, which I really upped the amount of number of subdivision to be able to get the curve of the tube, which in this case was too much for our holes. So if we go back to our number of points, or intermediate points, and we can then just bring those down, and even maybe change it to uniform 2, to something that's nice and smooth. But again, there's something going on here, and that's the cap type subdivision isn't quite enough, because if we're looking down the length of this barrel now, these lines here, they're what are creating the curve of our tube. As you can see, the various different holes that are causing problems with the overall subdivision of the tube, and it's breaking and losing its form. So we can see we're going to have to do something with that, because if that's a straight now, we've completely lost our curve. So let's go back to the extrude object, go to caps, and then just try and bring this down, and all of a sudden we're getting a nice our curve back, and the correct amount of subdivisions, because you're going to need a couple of subdivisions, because after all, this line between here and here is a straight line. So between here we've only got one real subdivision, so it's still going to be, you're going to be relying on the Fong to be able to shade that subdivision line out. But again, it's probably best to just try and use actual real subdivisions to do it. And there we go. Let's turn to isoparts. So that's basically how I'd go about doing those holes in our machine gun heat shield thing. Well, there's one thing you can also turn on, obviously, is because we don't want nice sharp edges or horrible sharp edges over everything. We're going to turn on our caps, or fillet caps, and bring them size down a touch. Maybe do that. And now we have a nice smooth cylinder with holes in that actually are now good enough to be able to use in on a machine gun model. And again, because it's all parametric, we can go back and we can alter this anytime you want, and you can actually see the holes interactively change. You can even see the bend object doing its thing. So I hope that's helpful, and it's not just for this particular thing. If you look out, and you can use this technique for pretty much any type of cylinder with holes in it. Like I said, just throw any kind of spline in there and you can cover quite a lot of eventualities. So anyway, I hope you like it, and bye bye.